Okay, in example 8, it says to find all the values of x in the interval from 0 included to 2 pi not included that solved cosine cubed of x over sine of x is equal to cotangent of x. So we're actually looking for some number solutions here. So it gives us here some ideas of things we need to remember. First thing is, if we have a fraction that has a variable in the denominator, remember that denominator cannot equal 0. So that means that our domain is going to be that sine of x cannot equal 0. So we've got to watch out for that, because we could get that solution that would give us this, but it really isn't true for the problem, because that'll put 0 in our denominator and make it undefined. Alright, so the second thing to do is probably change everything to sine and cosine. Where sine and cosine are easier to deal with, and I told you before in one of the other videos that if all else fails and I'm not sure what else to do, I always go to sine and cosine. Alright, so also you can multiply both sides by the denominator. Remember to always get rid of a fraction. So we don't like fractions, get rid of them. You can always factor. Watch out for Pythagorean identities, and then once we finally get to the very end, we're going to solve using our unit circle. Alright, so here's our problem. So we got cosine cubed of x over sine of x equals cotangent of x. So the first thing I'm going to do, I've already done my domain, is I'm going to change everything to sine and cosine. So I'm going to take that cotangent of x, and I'm going to look back at my quotient identities there, and it tells me that cotangent of x is cosine of x over sine of x. Now, we notice both of these have the same denominator. So to get rid of a fraction, remember, we can just multiply by the denominators. Well, since they're the same, I only have to multiply by one of them, because that's going to make this cancel and this one cancel. So we end up with cosine cubed of x is equal to cosine of x. Now guys, just think back to algebra, okay? When we had like an x cubed and an x, we said anytime we had more than one form of a variable, we got it set equal to 0 so we could factor. Same thing here. I have a cosine cubed and a cosine. I've got more than one form of the same trig function, so I need to set it equal to 0 so I can solve. So I'm going to subtract this cosine of x. And so I'm going to rewrite what I've got up here. So I have cosine cubed of x minus cosine of x is equal to 0. Well, I already gave you a clue because we set it equal to 0 so we could factor. Remember, your first step to factoring is greatest common factor. Well, cosine cubed and cosine both have a cosine in common. So I'm going to take out a cosine of x. When the first one there, cosine cubed, I have 3 of them. I took 1 out, so I'm left with 2. So I have cosine squared of x minus cosine of x divided by itself is 1 equals 0. Now, I could probably still work this out if I separated them, set them each individually equal to 0, but anytime I see a trig function squared and a 1, I think Pythagorean identity. So I'm going to come over here to the side for a minute in a little bubble, and I'm going to think, was there an identity that had a cosine squared and a 1 in it? And there was. We know that sine squared plus cosine squared equals 1. Now I need cosine and 1 to be on the same side, so I'm going to move this cosine squared over. And so when I do this, I get sine squared is equal to 1 minus cosine squared of x. Is that the same as what I have in the parentheses? Well, no. In parentheses, my 1 here is negative and my cosine is positive. And in the thought bubble, my 1 is positive and my cosine squared is negative. But since they both have different signs, what would happen if I divided everything inside my thought bubble here by a negative 1? So I would get negative sine squared of x equals negative 1 plus cosine squared. Or I could rewrite that that right side. That would be negative sine squared of x is equal to, I'm going to put my positive cosine squared of x first, and then my minus 1. Now, is this the same thing that's in the parentheses? Oh, yes, it is. So therefore, I know that cosine squared of x minus 1 is equal to that negative sine squared of x. So I'm going to replace that here in the problem. So I'm going to plug that in right there. So I have cosine of x times negative sine squared of x equals 0. And there's different steps we could take from here, but if nothing else, we know we've got two things being multiplied equal to 0. So I can set them each equal to 0 and solve. Alright, so where is cosine of x equal to 0? Well, think about your unit circle. Cosine is your x value on your unit circle. So where on my unit circle is x equal to 0? Well, hopefully you're thinking up here at the very top and the bottom, because on that y-axis, x is always 0. Well, where's that at? Top is at pi over 2, and the bottom is at 3 pi over 2. Now on the right side there, that negative sine squared of x equals 0. First thing I do is got to get sine squared by itself, so divide by negative 1. And so I've got sine squared of x equals 0. Now I could try to solve this, but I'm thinking, wait a minute, I've written something similar to that before. Isn't that my restriction, that sine squared of x or sine of x cannot equal 0? So it's not quite the same, so I will go ahead and continue. So let's get the square root, or get sine, so take the square root. And so we got sine of x equals plus or minus 0, which remember, plus or minus 0 is the same as just 0. Now this is exactly what we had up there at the top, isn't it, in our restriction? So this one will not give us any answers. This is a restriction. Sine of x cannot equal 0. If it had been something that would work, then we could keep going, all right? We would have been able to solve for x otherwise. So we only had two solutions in this problem, and they are right there.